Welcome. Thank you so much for joining us tonight at Remoticon. My name is Mike Stish. I am editor-in-chief of Hackaday, and it is my honor to introduce tonight's keynote speaker. It's pretty clear that the future is definitely going to bring self-driving cars. And the question is, when and how are we going to have those self-driving cars? The good news is Alfred Jones is working on those answers. He's the head of mechanical engineering and manufacturing at Lyft's Level 5 self-driving division. Now, Level 5 is the real deal. This is the cars that can drive all by themselves without human intervention, and they can drive anywhere that a human driver would be able to travel. Alfred's team is responsible for designing and developing the features that ensure reliability and ensure safety of this hardware, which is obviously a huge concern. He has degrees in both physics and mechanical engineering and is also an MBA. We have been honored to have him as an expert judge for the 2019 and 2020 Hackaday prizes. Please welcome to the Hackaday Remoticon stage to deliver a keynote talk, Alfred Jones.
Woo! Yeah! I can't hear anybody, so I have to cheer myself on. So I apologize in advance. Hi, everybody. I'm super excited to be here. I can't wait to share with you what's on my mind about autonomous vehicles. And it's really great. First, it's been a crazy day in the Jones house, and we've been a lot of emotions going on with what's going on in the world, but we're celebrating now, and now I'm celebrating with you. So let's jump into it as I share my screen right here. All right, I want to talk to you about autonomous vehicle hacking, specifically self-driving overview and the design and development for safety. How do we do it? Why do we do it? What is it? First, a little bit about me. My name is Alfred Jones, and I like to consider myself a product developer. I love making things. I love making products. I hack in every aspect of my life, whether it's personal or professional. Over the past 17 years, I've made a ton of products that I'm very proud of from a slew of different companies, starting with the first product that I ever worked on was Razor 2 flip phone, back when the good old candy bar, no touchscreen was all that there was. But now, as of late, what I work on are autonomous vehicles, specifically for Lyft. Lyft is an American rideshare company, which mission is to improve the world of transportation. And really thinking about the future of what rideshare looks like, what transportation looks like. And the future, is it autonomous? I don't know. We might find out in this presentation. But before we get into it, I want to give you all some background, right? We talk about these different levels. Mike even said level 5 is the epitome of autonomous vehicles. But how do we get to level 5? Well, first, we got to understand that there are different levels, and there's actually 6 levels, by the way, starting with level 0. And within those levels, there are 2 different pillars. There's one that is the driver monitors and drives in the environment, and the other one is the autonomous vehicle. Level 1 is what is pretty much every single vehicle that was been created ever since that first vehicle, probably even before Ford Motors even had their vehicle, but the Model T, all of those are level 1, the car that we know and love. And what makes that level, or level 0, excuse me, what makes that level 0 is it is just completely driven by a human. The human uses their eyes to see the world, their arms to steer the car, and their feet to press the gas. But then there's level 1. Level 1 is where we first start to assist the driver. The best example of level 1 is your cruise control. Now, every car that is modern has a cruise control, and it's just simply, setting the speed, but yet you still have to drive the vehicle. You still have to see what's on the road, and you have to be ready from a safety standpoint to take over at a moment's notice. Then there's level 2. Level 2, now, if you have a level 2 car, I want to be your friend because I want to drive in that car because that's a cool car, probably an expensive car. And those are the cars that have the driver's assist, where it will stop and brake for you when you're on the highway. It will even steer and keep in lane. But pretty much that's it. So it's not a self-driving car. It's a self-steering, self-stopping, and automatic go car. But then when we get to level 3, we start to really dive into what is autonomy. And this is the cool part. This is what we're starting to see today, brought to you by Tesla and companies like that, where now there is an autonomous mode that allows you to take your hands and your eyes off the road and think about other things. However, the driver must still be engaged from a safety standpoint in case something happens. Typically, even though that these cars can do that in these very controlled environments, you really don't want to do that, right? You don't want to trust that type of vehicle because if something just kind of pops up, you'll lose control. Then there's level 4. Now, level 4 is when we're really talking about autonomous vehicles, and this is the car that I want to commute every day to work in. Why? Because then I could take a nap or go to sleep. Now, the key unique thing about level 4, and level 4, we're going to talk a lot about level 4 because level 4 is really where the world is today, and that is the most obtainable level of autonomous vehicles. Why? Because what you're creating is an autonomous vehicle that could ride safely and reliably in a certain set of conditions. We're going to talk about those conditions, but those conditions could be, on the highway, in certain cities or certain roads. But then there is the end all be all, level 5. Level 5 is the top floor. It's the best you could be. This is full autonomy. Level 5 car, you don't even need a driver. It doesn't need an owner. The car can drive around by itself. The best way to think of level 5 is artificial intelligence, full artificial intelligence. Why? Because essentially what you're saying with a level 5 car is you're removing the human and you're putting in a different brain that can think and react just like a human can. And for those of you who drive, and I know nowadays a lot of us don't, but for those of you who drive, if you're driving down the road and let's say, God forbid, a fly flies into your eye. You close one eye, you can kind of squint until you drive to the side to get safe. That is the type of safety, reliability, redundancy that you want in a self-driving artificial intelligence at level 5. So when we're really looking at an autonomous vehicle, this is what we're experiencing, right? Where all these pictures that you see, you have these real life scenarios with what you see on the left side of the autonomous vehicle scenario. There's cars, there's people, there's bikers, there's pedestrian crosswalks, there's stop signs, there's traffic lights. These are all things that we take into account as we're driving. So how does an autonomous vehicle do it? We all know how humans do it. So let's talk about that. But before we talk about that, I want to make one thing clear. The road is crazy. And believe it or not, that is somebody really driving like that. But it's very unpredictable. A lot of things can happen to a crazy driver doing a two-sided wheelie, or something as simple as road construction that pops up out of nowhere. An autonomous vehicle, in order to be safe, must be able to react safely in all of these situations. So we look and think about the autonomous system. What we're really doing is recreating the human that is driving that car. And we're starting all the way on the sense side. We're looking at how do we gather the information from the environment, from the world, right? From what we see, what we hear, maybe even from what we smell, to kind of take that and then digest it from in order to interpret it and filter it and make some data choices, and then figure out what is the safest course of action before we initiate, right? And if you think about how that progresses, essentially what we're doing is we're sensing, we're perceiving, we're deciding, then we're acting. And that, again, is the eyes, the ears, the brain, or the body, which then breaks down into the hardware portion, which is what I focus on, which are the sensors, the compute, the power, and the motion control. So the first thing when we peel back that onion of sensors is we talk about cameras. Now, cameras are fantastic. They have high resolution. They're able to see and characterize a lot of stuff. Tesla has a self-driving system that only uses cameras, and cameras are great, especially if you have stereo cameras, because it allows you to perceive the environment and be able to tell what different things are. It helps you from a lane keeping standpoint. It lets you determine traffic lights and different types of vehicles. There are stereo cameras that allow you to kind of determine distance, but ultimately cameras are not good at determining the distance of things. Again, they're high resolution, they're low cost, but distance is something that cameras you can't really tell because it's technically a 2D image. And they're very sensitive to different lighting conditions, right? If you drive in somewhere that's pitch black, that has no surrounded lighting, and your dynamic range is not high enough, you won't be able to use those cameras. But cameras are great and cameras are used. There's another type of sensor called LiDAR. LiDAR, which is similar to a radar, doesn't use radio waves. It uses light beams, and it projects light beams back and forward, right? So for those of you who are not familiar with a LiDAR, it's a mechanical sensor that spins a light around with a projector and catches that light back and creates this point cloud. Now, LiDAR are super fantastic. They can determine the shapes and 3D objects very clearly with very high fidelity, but they can't see things like color. They can't see things like signs. They can't see the markings in the road. And LiDARs are extremely high cost and low reliability. Why? Because they're a moving type sensor. And then there's the good old radar. Radar, which uses radio waves to detect objects, are great in a lot of different conditions, especially when you can't see, you have no visibility. If there's fog, they're really fantastic in, but they're very low resolution, right? Radar can't pick up small objects. Radar does not see the fine shapes of an object, right? What they see are, blocks, and they determine that to be an object. And another bad thing about a radar is they're very noisy. Radar, unlike a LiDAR or a camera, they're not a beam of light. They're not a straight line. Radar creates this radio wave effect that creates a lobe, which can couple and ground to different types of materials and surfaces, right? So that radar is very dependent on the vehicle positioning, what's around it, the interference from other different radar or in a scenario, bouncing off of signals if you go through a tunnel. So what I'm getting at is all of these sensors are great in some ways, but they're not great in other ways, right? Here's a side-by-side comparison of all three sensors. Now, mind you, there are other sensors that some autonomous vehicle companies use, such as sonar and other types of lasers, but these are primarily the three most important sensors. But if you notice, if you look at this graph, you'll see a common trend, right? Whereas where one is weak in one category, it is strong in another, which a different sensor is able to compensate for. A really good example of a bad situation is this is a LiDAR point cloud. And you can tell because of the fidelity of all of the objects there. And those blue dots that are in that circle, that is smog coming out of that RV's exhaust pipe. Now, when the vehicle was riding around in this scenario, it stopped because it did not know what that object was. But what we've since done is train the object to work with the camera and the radar to cross-reference that phenomenon. And what we call this is sensor fusion. So everybody is doing this now. Waymo, Cruise, Zoox, what have you, where you take LiDAR, you take camera, you take radar, and you put them in a constellation around your vehicle in a way that they work together. This ultimately allows you to really understand your environment. Now you can say with confidence that this is a car, that's a bike, this is how the lane is turning. and working all together. And the most important thing is safety, 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 right? You want to make sure that when this vehicle is riding on the road, if you or I were walking across that street, I want to make sure that that vehicle knows that I am a human walking across the street, and it should react accordingly. So those are sensors. But the funny thing about sensors now, as I said before, the difference between level 4 and level 5 is artificial intelligence, right? Now, you and I, as artificial or real intelligent people, compared with an artificial intelligent, you would not need to understand an environment in order to drive in it before you got there. Whereas at level 4, in order for an autonomous vehicle to work in an optimal way, it needs to understand the environment. And the more data that we can provide for it, the better it can understand its environment. And this is something called mapping. And mapping is something that uses a whole bunch of different types of maps to create an autonomous AV map. And what are those maps? Those maps look like Google Maps. Those maps are maps created by LiDAR and camera. And those maps are also maps that are created by autonomous vehicle companies to create scenarios, right? So they'll take the maps and project what is a proper route on a road, what is a proper stopping pattern, where are the crosswalks, and it will train its autonomous vehicle on these maps. These maps are very important, and what we do is we use machine learning with tons of mapping data in order to understand and determine how do we react to the environment. And the way we build these maps it's actually quite clever. A lot of times, if those of you have seen an autonomous vehicle driving around, here in California, we have an autonomous vehicle company called Zoox and Waymo, and also us. And a lot of times when we're driving around without passengers, we are mapping the environment in order to understand it better, in order to understand what is the frequency of traffic, what is the frequency of pedestrians, how are they maneuvering. And then we take all of that data with these maps, using our machine learning algorithms to further predict what the autonomous vehicle should do in these settings. And that's what we do with mapping. And essentially, it ends up looking like this, right? Where you have this scene scenario, it breaks it down into what are the different lanes and how everything works. And then the machine learning coupled with the sensors predicts where are the vehicles going in this scenario. It's actually pretty amazing stuff. Every time I ride in an autonomous vehicle and I see this happening, I just can't believe it. But this is a great example of, all of this working together: sensors, sensor fusion, machine learning, and mapping. What you see here is in the middle is an autonomous vehicle that is riding down a trajectory down an already mapped lane. And what you're also seeing are in these boxes are different objects where you see parked cars, you see this big parked truck right there that comes up in purple. There's a pedestrian walking in that yellow box right there. But the most important thing that's happening is this red box. And in conjunction with that green, then purple, bigger box, right? There's a biker, two bikers actually, biking alongside of the autonomous vehicle. And what you notice, and if you and I were driving and we saw these bikers coming and you also saw that truck in front of you, you might say, I might want to slow down at this point to let these bikers pass. And that's exactly what's happening, right? So the vehicle predicted that these bikers will go in this particular route, and it stopped. And that barrier that you see right there is kind of like a safety barrier check. It's like, okay, something's about to happen here. Stop, perceive, decide, okay, keep going. And that's what's happening. It's pretty fantastic stuff. Super cool. Motion control, hardware. So now let's dive a little deeper into the hardware that makes this work. The stuff that really gets me excited. Motion control are the control units that we use in order to control how does a vehicle stop, how does it start, how does it brake, and the engine, right? So it's very important once you design your computer with your sensors to be able to control that vehicle. Vehicle companies nowadays are designing their vehicles in a way that it's more easy to tap into the motion controls already of a vehicle, so you don't have to custom design your own. You still should, in order to limit your latency and ensure your safety. But ultimately, you want to make sure that your vehicles are road compliant. And anything that you put on the road, it has to be roadworthy to the point where you don't want something to fail while it's driving down the road at 80 miles an hour. That would be catastrophic. When we think about the design process, you might have heard I kept saying safety, 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 safety. Safety is the mantra when anybody's in the automotive industry. But I think even more so in the autonomous industry, because now we are putting our lives in the hands of a robot. So when we're thinking about it from a hardware perspective, also from a software perspective, but we want to think safety, safety, safety. And in conjunction with that safety, we think reliability, scalability, and serviceability. And why do we think those? Is because, well, if you an autonomous vehicle, especially for rideshare, is more like a bus or an airplane, where you want to make sure that you can quickly service it. If there's a part that doesn't work, you could take that part off, put it back on, go through your checklist to make sure it's safe, and then put it back out there. Especially if it's something that is for rideshare. And then lastly, there's this huge Lyft logo here. For those of you who don't know, if you can't tell by the color choice of the logo, we are very festive at Lyft, and we really think about the customer experience whenever we are doing any type of product conception or any type of design work. So that's something there that I really instill a mantra in my teams to really think about the product experience and how do we design our autonomous vehicles so that they're approachable and fun and not intimidating, because we want people to really embrace it and not shy away from it. So diving a little deeper into the design process, I wanted to share this with y'all because this is something that is very near and dear to my heart in every product that I do. And this is something that is important for any fellow creator, hacker, designer, builder, engineer. This is the wheel of success. This is our design process, right? Whenever we have an idea or a requirement or a goal, it starts off as a problem and it enters into this circular loop where we analyze and we do design work, right? When that design work could be, on a napkin, that analysis could be a hand calc. But ultimately, you create some prototype and then you build something and then you test that. Test. Testing is the most important thing that any builder, any hacker, any engineer should embrace, because that's just what makes us better. We want our things, our hardware, our ideas to fail so we can then improve and evaluate that and do more research to prototype and test and improve and research, but ultimately it will give you a solution. Now, the caveat with this is, the best is the enemy of good. And a lot of times you want your product to be the best, but you have to find that happy medium so you can get to a solution. And ultimately, by understanding your project tenets like safety, reliability, serviceability, and scalable, you will be able to exit this circle with a solution that gets you a really, really fancy looking autonomous vehicle over there, I might say. History of the autonomous vehicles that I've worked on with my team at Lyft, it always starts off with a pretty janky prototype, right? How do you just get to a basic understanding as quickly as possible? And that's what you see all the way here at our alpha car. And then we've iterated along the way with our beta and our beta plus. And unfortunately, I'm not able to share with you our 4th generation, which we just yesterday, we did a marketing photo shoot with. So we will be sharing it with the world, but it is literally the best autonomous vehicle. I can't wait till you all see it. But our design process, our detailed design process, is really dives into all of the things that make automotive, aerospace, and product design its best. And we bring people, engineers from all of those different industries to custom design and build all of our hardware from scratch. With exception of the vehicle, there's a lot of different approaches. The way that we do it is we choose to modify the vehicle in such a way that it will be safe, reliable, and autonomous. And analysis and test. Analysis and test is something that is very important. And we do all of this in-house with my team, where we look at things virtually and empirically. We understand all of the fluid dynamics of things. Thermal is something that is extremely challenging when designing for anything automotive, especially autonomous. Why? Because processors and compute gets very hot. Cars get very hot. There's solar loading. If you ever sat in a car in the desert in the summer, you know what I'm talking about. But there's other things you have to consider, like rain, snow, and sleet, salt water, so forth and so on. So when you're designing these things, it's not as straightforward as just slapping something on and going, not if you want to scale something up in order to provide a product for rideshare. But ultimately, it starts with the design, right? Again, like I said, when thinking of an autonomous vehicle, you want to think of how do you make something that is approachable? How do you maintain a design language so you're telling a story with your product, as opposed to just having just an ugly vehicle that drives itself, right? Anybody can do that, but can they make it in such a way that is appealing to passengers and pedestrians? Some more fun facts about what my team does. We do all of this in-house. We design, we build, we test, and we have a pretty cool laboratory where we work on our vehicles hands-on. So super excited to share that with you. And ultimately, that's Lyft. I'm going to skip over this last slide and jump to question and answer. Thank you for your time. I hope you guys enjoyed it as much as I did. Mike, do you have any fun questions for me?
Yes, absolutely. Thank you so much. That was a wonderful keynote, Alfred. And I was really just thinking about what it takes for your team to take a vehicle and not add the sensors, but actually make the actuation part of it happen. So can you just plug into the CAN bus of an existing vehicle and do the steering, acceleration, braking, shifting that you need to for the vehicle, or are you altering those systems?
Yes, that's a great question. So not only do we have to alter those systems in a functionally safe way, by the way, we also add our own motion controls to be able to have a much better latency and control over those sensors. Without getting into too much proprietary, you want to make sure that those buses and whatever motion controls that you add to the vehicle, talk to your system as quickly as possible and safely. But we also add redundancies in there in an effort to make sure that it's safe while driving on the road.
I also think a lot about the sensors that you have in the vehicle and like characterizing those. Like, for instance, if you get in the car at the end of the night after staring at this computer screen, you might notice like, oh, I can't see as well as I normally do because my eyes are tired. Or you might get into a heavy rainstorm and be like, I need to slow down and make sure that this is safe. So in making sure that the sensors that you have on your system are in the top working order that you expect them to, is it different? Is it already a solved problem like aerospace has sensors and they know how to make sure that they test those? Or are there new problems here with LiDAR and more advanced sensor fusion?
Yeah. Fantastic question. It is not like aerospace. It is not a well-oiled machine. It is still very much in development. Sensors need to be recalibrated very frequently. And one of the challenges to scaling up an autonomous vehicle is how do you do that in such a way that your vehicle can either recalibrate itself or it's more effortless. So, I mean, to answer your question, we're creatively developing ways to work on that, to improve that, to make sure that they work well with the vehicle, but then also so your design works well vehicle to vehicle to vehicle in the same exact way, right? So it is a challenge. I don't have a precise answer because we're still working on that, but right now what most companies do is, very often they calibrate their vehicles frequently. It's kind of like how I referred to the airplane check, right? Before you go on a flight or when you land, you check your instruments and what have you. Calibrating a vehicle, checking your vehicle for safety before you go out very regularly is very similar at this stage.
So I liked your explanation of how, we have these sensors that are trying to fill in for the human senses. And it seems, like it's hard to build an Android, right? And you're building an Android to be able to
Yes.
sit in this driver's seat and drive this thing, which makes me think that all of our roads have been designed for humans to
Yeah.
operate on. And so do you see a future of roads that are designed for robots as a possibility, in order to get us to the point where self-driving can be proven before we take that huge step
Yes.
to robots being anywhere?
Yes, definitely. I do. I think that is a huge step that societies will have to embark on once the value of autonomous vehicles are realized. I think putting autonomous indicators and markers and on the highway is probably the first step. One of the first types of autonomous vehicles we'll start to see um, are within our freight delivery, right? Doing an autonomous vehicle on the highway is the easiest form of autonomous. Why? Because it's very consistent. It's a long trajectory. It is a constant speed. So if we are able to help our infrastructure in getting product from one end of the country to the other side, or wherever you are, you could easily see the investment, the return on investment by putting that infrastructure into like a highway system. But then the next step would be the cities, right? Cities might want to not only they might want to change out their street lights in an effort to have radio sensors on them. So not only will the camera be able to detect that it's red, yellow, or green, but maybe it emits a signal that says, okay, it's red, yellow, or green. And that will be very, very appealing to cities because, again, we're in my company, we're making vehicles for rideshare, right? So you're helping people maneuver around the cities, limiting pollution, limiting city congestion if you're by limiting the amount of vehicles that are there, right? So I guarantee we'll see more and more stuff like that, but the industry has to converge on what those things are, right? Before they just start popping up, and I really think they'll start with highway transportation first.
I think the last question that I have is one about manufacturing. And I hope this isn't a short question, but it seems like automotive industry is already set up for manufacturing at scale. Are there any real challenges once, problems of what sensors should we use? How should we do the sensor fusion? How should we stitch everything together? Is it going to be difficult to scale up self-driving manufacturing, or do we have the resources in place for it?
Great question. Once there is an architecture that is proven, it will be as easy for the automotive industry to scale it up as it is any other vehicle. It will take time, but essentially the part that we do in tech is really accelerate the development of the technology and really figuring out what is the best architecture in order to make a self-driving vehicle. Now, in the presentation, I talked about LiDAR, radar, and camera being a really efficient sensor fusion, which it is. However, if we look at the radar, which is very expensive and it's low reliability, it is not the most optimal thing to put in every single vehicle because you'll have a high failure rate, especially statistically, as you increase the amount of volume. Also, it's a lot of moving parts and it's very expensive, right? The cheapest LiDARs are, tens of thousands of dollars. So I think the industry as a whole needs to figure out the right system that will safely work in the right environments in order for the car companies to have that blueprint in order to manufacture. Now, companies like Waymo have partnered with FCA. Cruise has partnered with GM. So the auto industry is already trying to figure out how do we adapt to this technology. But again, the tech needs to be figured out first. And I think there's a lot of different bets being played. Um, uh, Elon Musk is a very firm believer that this can all be done with cameras. And if you are able to do it with cameras, let's say you can do it with cameras and just radar, and most cars, or a lot of cars these days, are starting to incorporate your radar, then you can really create a system that is very cheap and reliable. But then how do you do that safely? I think if we had cameras and radar in a vehicle with these sensors in maybe the street or street lamps and what have you, I think we would be able to greatly accelerate that architecture that that automakers can make. But again, you still want to make sure it's safe. It will be a little while before we actually determine what safety is, and we're getting there. We're learning. But I'm very excited to see what's happening in the world of autonomy. And I can't wait until all of you get to drive an autonomous vehicle, because it is absolutely awesome.
I like how you put that. Wait until we all get to drive an autonomous vehicle. It's like if you think about, I'm going to hang up the phone, right? That used to mean something. You'd literally hang up the phone, or like,
Yes.
I'm going to roll down my window
Yep.
in my car. And so it'll be fun to put the nail in. I'm going to drive the car, and have that be an antiquated phrase. Alfred Jones, thank you so much for all of your time. We really appreciate you giving this keynote. I found it very inspiring to find out the very difficult engineering problems that people are facing that are very new to society to figure out, and to see that very competent and inspiring people are the ones working on them. Thank you.
Thank you very much. Thank you for having me.